day to you. This is Anagalactic on the day after Christmas 2023 from Chico, California. Today we are going to present the theory of everything. This has never before been attempted because there are several current obstacles to the theory of everything. And your first question must be, even if you think you already know, what is the theory of everything? It's important to know what I think it is. Well, it's not important what my opinion of it is, but I must convey to you what is actually known right now about the theory of everything. First of all, what are you talking about? These grandiose terms are a bit of an annoyance in pure science because the theory of everything is obviously megalomaniac, and it signals a problem, possibly. Because if someone is willing to use this phrase in science, theory of everything, they're declaring themselves to be the king of the jackasses. Nobody in their right mind would come up with a phrase like that. So what's going on here? What could that possibly mean? Theory of everything. Well, let's take the two words. We're not going to go too far with this because you can tell I have a thing about naming things right. But I've also learned it's important to notice when something is purposely named wrongly. If you want to use the adverbial, wrongly, or just as we Americans prefer to say, since it's one less syllable, it's just plain wrong. To have a term like that at all. It's like black hole or Big Bang. What, are you out of your mind? Well, you see the trend here. There's a trend towards nonsensical terms, foolish terminology, anti-scientific approach to something that we're supposed to be all agreed on the rules. You don't name something like that in science unless you're catering to the public, perhaps for propagandistic reasons. So let's take apart what is currently meant. Now, who is talking here? Who do I have to consult? I should say whom, shouldn't I, if I'm a real pedant? I'm not a real pedant. As you get older, you drop the pedant deal. It's still there, but you try to ignore it and not give it any room to grow further, because we're here to communicate, not to be nit sticklers, okay? But when it comes to a term like the theory of everything, I should have to say, we do need to pause here to be sure we know what we're talking about. Theory already means, well, we don't know something. Whenever the word theory is loathed in science, we don't like theory. We're forced to it at the edge, though. For obvious reasons, if you're pushing the envelope, which science always is, you tend to use unusual terms. I'll just be generous. So theory, okay. So this is, right now what we're talking about is theory, okay. You don't know. You don't know. That's what theory traditionally means, and in this case, quite rarely these days, it's actually still called a theory. Well, I can tell you why. It's because it's considered to be the only theory left. There's no other theory. That's why it's called the theory of everything, is because it's meant to unify everything. What in the world do you mean by everything? Well, that is actually well defined, and so I will tell you what I have been told by contemporaneous science. This is the edge. What is the theory of everything? It's the unification of quantum chromodynamics, or quantum electrodynamics, or quantum field theory, all of which have the word quantum in it, which we're going to need to define, aren't we? But we're getting there. What's the other part? It's to unify quantum, electrochromo, anything mechanics dynamics, anything with the word quantum in it. That's why I say, that is now Q. We're not going to use that stupid word anymore. Quantum is the most misleading scientific word that's ever been invented. It was actually invented by Albert Einstein, who knew what he was talking about. But the way people are using the word quantum now is not what Albert Einstein was talking about, nor was Max Planck. So what is meant by quantum? Footnote, let's complete the main thought. It's the unification of Q with G. And now you have a mnemonic, and I hope I helped you there. My job is to be a teacher, which means to get across information in a coherent, logical, terse fashion for understanding, pure and simple, so that you know what I'm saying. I have to know what they're saying to tell you what they mean when they say theory of everything. T-O-E. Toe. That's opposed to the grand unification theory, which you may have heard of. Do you know what that is? That has to do with the strong force now. Although historically, you may find out that that changed meaning. And one of the reasons that changed meaning, not to go off on too great a digression, but this applies, nobody is really sure what the nuclear force is. There are 3 definitions of the nuclear force, and one of them now is the strong force. But another one has been added called the weak force. And both of these have particle-defined transmitters. So there's something between these things at all times that goes by different names. It's sometimes the W or Z boson. It's sometimes as a photon, which is often called, and I think there may be a distinction here, a pseudophoton. But what is actually being said in the grand unification theory is not what you and I are after right now. We want the theory of everything. And that is the equation. As I was told, and I will be correcting this for your benefit and mine, while I explain to you the right answer, which nobody else knows, so this would have to be also theory. So I'm going to give you my theory, except it's not theory. So first I have to tell you, what is the puzzle? Because that'll give us the goal. Q equals G. Q equals G. That is called quantum gravity. Quantum gravity. And that's where we begin today, after only 8 minutes of approach to this topic. To be sure that we're all on the same page, there is no way that anybody is on the same page yet. Gravity, which kind? And quantum, which kind of that? What do you mean when you say gravity? Let me fill you in, because I already know, and you may too, but it never hurts to be reminded of the basis, the foundation of whatever we're talking about. It never hurts to go back. It's just that most people don't think they have time. You have to make time to get the right path. And that's my job. So the definition here of quantum and the definition of gravity must be fully defined right now, or there's no hope of that theory being solved. Okay? So what is gravity? Space-time. And what is the quantum? It's the difference between a particle and continuity. I am 100% sure that there is not another scientist alive or dead who would ever put it the way I just did. And I can state now, in modern terms, why that is the case. Because nobody knows what gravity is. And nobody knows what the quantum is. And it's just a matter of a double flip of the coin whether you think there's any hope of matching those up at all, since nobody even knows what they're talking about. Now, in each separate province, which is gravity, which is space-time, so we're going to call it that from now on, and the realm of quantum fuck your head business, quantum fuck, that should be abbreviated Q. What is Q? Let's start with the easy one. What is G? G has always been known by human physiological sensor, that is vision, hearing. We have something in our inner ear that allows us to stand up straight. I have never, in all of my educational experience or research experience, ever heard anybody explain carefully, because this is something every human being can understand at any age, is that when you stand up and you're capable of standing up, that can be explained geometrically and mathematically and algebraically, visually, perceptually, with a pure feedback loop from the universe of what it means, the miracle that you as a child can move your chair away from the desk if you need to and stand up straight. Do you have any idea of how profound is that motion and that ability? I am not a puppy lover. I am not a humanist. I am not an whatever they call it when everything focuses on human beings. But we are human beings, and that will always be one half of science. So get that through your head right now, because that's where we're going. If I give you, as I have promised, I've sworn to give you the theory of everything, well, that is the unification of gravity and Q. G and Q, with an equal sign between them. That is what every single highest paid scientist would swear to all the gods, real or unreal, is the goal right now. Quantum gravity. So we'll begin with G, and then I will make Q into the simplest thing, and it'll be a tie. Whether G is simpler to understand or Q. But nobody will ever tell this to you the way I'm going to tell it to you. And that is exactly the definition of the solution to quantum gravity, which is a theory. The theory itself has been so strongly questioned that now we're forced to admit that it's at least equally likely that there's no such correlation. And what is called the quantum and what is called gravity, there must be an adjective to describe their relationship if they're completely unrelated. But are they completely unrelated? Let's make sure we know what gravity is first. And then we must know what Q is. But here's the problem with Q. Nobody knows what Q is. There is zero definition of Q. And every time you see the word quantum, you are seeing a human admit that their logic system that they trusted in, all scientists swear to this before God or anything. That Q has to be understandable according to what we already know. And that's the fail point. There is something about what we already know that forbids us to interpret Q. Nobody can even say what it is except I can. So that will be the second part of this lecture. The first part is on G, gravity. When you stand up from your chair, you create the radial line in spherical space. You've created the perpendicularity in spherical space because your feet are basically perpendicular with your body. And the line of gravity that goes through the top of your head and all the way through your misshapen body, right down through the part that's at the end of your main torso between your legs, keeps going to the center of the earth. That's the center of a sphere. Whoever told you that? There's a reason nobody ever told you that. That you just defined spherical space and spherical linearity. You also, by yourself, defined trigonometry because you invented the line in spherical space. You may recall that we were never taught any of this. Instead, we were taught a straight line in empty space. That's insane. But it turns out, if I were actually to say that and mean it, and I hope you realize I didn't mean it, the reason why the Greek line in empty space, even though it hits two infinities and creates a derivative infinity called 0, we had to do that first. And so this was divinely blueprinted, that we would get the linear number system before the spherical number system. But nobody has ever even guessed that there might be a spherical number system. So the spherical number system is a two-component whole number system of reciprocal numbers that creates spherical space. And the way we know that is by creating the center of the universe and the edge. And those two are imaginary numbers. And since the edge is the integral, obviously, we can give it an imaginary number called infinity, but this is spherical infinity. And that's spherical infinity over 1. And that's one of the two component numbers. For any spherical number, we'll have one number that looks like this, with a big number on top and a 1 on the bottom. And if you think that's a linear number, you look back at my previous lectures and you'll realize the folly of saying that. But you are right. Because it can be transformed into a linear number by taking out the 1. Because any number over 1 reduces to its linear representation. But any number over 1 is not a linear number. Some of them can be made to be linear numbers because 2 over 1 is definitely 2. 3 over 1, definitely 1. Spherical infinity over 1, that's definitely spherical infinity. But you cannot leave out the 1, because the 1 makes it a division number. And this component of the two-component number has a reciprocal. And that should be obvious. The center of the universe is the reciprocal of infinity. So the center of the universe, this is a geometric universe. So don't get your panties up into your crack. We already know of two componency from complex numbers, so I'm not going to challenge your intelligence by telling you a two-component number is exactly what science has been looking for. So that is a number divided by another number. But in the case of spherical numbers, it's a two-component number, and the rule for the first component is the number on the bottom is always 1. And the other component, the top number, is always 1. And that means that the component number is always 1. Because the two numbers are reciprocal, they multiply to 1. That's the basis of the multiplicative divisional closed system. It just so happens that the designer ordained that that would make spherical space, and here's how. When you have 1 over spherical infinity as the center of your number system, which means it's the center of your geometry as well, then you have a non-zero center. If you can grasp that, you may not need to listen to anything else I say. You can figure out the rest. But you're here to get something good. And this is Christmas, although it's the day after Christmas. In Ukraine, they celebrate the New Year for 7 days because they have 2 New Years. Well, why not have Christmas be the whole week until New Year? Isn't that what we do anyway? Isn't that what we would want to do if we thought we could? Well, Americans can't because we're overworked, as everyone in Europe knows. But I'm not. I have so much time, it's unbelievable. Although my time is running out, as for all humans it is. So, I hope you see that we now have 2 numbers, one which defines the imaginary edge of the universe, because this infinity is imaginary. It has to be because infinity is imaginary. Do you understand? But the fact that it's infinity over 1 in multiplicative space, which, let me tell you a new word if you don't already know it, this is proportional space. And the definition of proportional space numerically, it's closed. It's a closed spherical space. And here's the proof. Imaginary, that's redundant, but just it's important because we need imaginarity. There is an imaginary part of the universe. Where would it go? Where we see it. The edge is imaginary. So the edge is imaginary infinity over 1 that's imaginary spherical infinity. The line has 2 infinities, plus minus. File that. I can't go into any more multiple-houred lectures to explain every single thing I say. But the line is obviously crippled. The sphere is not. And one of the reasons is this is a continuous line. And continuity, as I already mentioned earlier in this lecture, is one of the keys to Q. Because the definition of Q is that you cannot be both continuous and discrete. The line, is it continuous or not? No. Is the sphere continuous? Yes. And that's a definition of continuity. An open line is not a closed line, but the only closed line we know is a circle in what we call flat space, which we see naturally, but we're talking about a sphere. And that's how we see most naturally, because the Earth is a sphere. The Earth is a sphere for a reason, and the reason is G. G. So the gravity system depends on continuous space, not linear space. Continuous space, not cubic space, not flat space, not square space, not straight space, curved space. Gravity proves that statement. It's a spherical manifestation of centripetal force. That's actually redundant, because there's only one centripetal force known in the universe. But you may have heard of two, and you may have heard of three. So let me name them. What is the force that forces something with mass to head toward another mass until it cracks into it? Gravity? Yes. Anything else? Magnetism. What else? There's one more thing, but it's subatomic. It's not gravity, and it's not magnetism. Those are macrospace manifestations that we can measure. Is there such a thing as gravity at microscale? Is there such a thing as magnetism at microscale? What do we mean by microscale? Subatomic. Subatomic. Because where would the center be in the universe if it were anywhere? It's the proton. So that's our working definition for the physical center. And now we want the geometric center, which may or may not have anything to do with the proton. We are not saying that yet. But we're saying there's a strong correlation going on here, because real space, as we perceive it, is spherical. And the universe itself proves that, because the edge is unbounded in all directions. All directions, that's spherical. We're not sure of that because we can't penetrate the edge. And so we're going to artificially bound the universe as if it were spherical, but knowing that it's infinite. Infinity over 1 is the edge. In proportional space, which is multiplicative divisional space, that means that the center of the system is the reciprocal of that infinity. That's 1 over infinity, which means that the center is imaginary. Imaginary does not mean unreal, but relatively speaking, or relativistically speaking, in fact, we're getting there, those are different terms, but consider the fact that the proton bends space. What does gravity do? Einstein taught us. It bends space. Could they be related? Obviously they are. What about magnetism? That is a very interesting phenomenon, because when we go to measure magnetism, it does not exist without electricity. And the converse is true as well. That is a spooky manifestation of the same centripetal force, and it's somewhere in between, but it's actually electrodynamics. So this has to do with the Bohr atom, which is made of a protonic core, with or without neutrons, and an electronic shell system. We need to understand those two particles in order to understand the quantum paradox, QP. I have proved that the quantum paradox can be reduced to one relationship. And the reason that can be done is that the quantum paradox is not just one thing. There's superposition, there's entanglement, there's the collapse of the wave function, there's the wave-particle duality, there's the polarity, that is the polarization paradox of light, which you can do at home and I can demonstrate to a 5th grade audience to their utter amazement. And the reason I know that, it was done to me. So the quantum paradox is the heart of the matter because we can't do anything with the edge of outer space. It's completely unknown. We don't even know the shape of the universe. To even imagine that we know whether it's expanding or not is the height of folly. And to think that we know how it began is insanity itself. We have none of those answers, not even as theories. And so we're forced to Q and G. Local phenomena that we can measure. But we can measure a lot of information that comes to us from the universe in the form of light. And that has been my goal for 2 years. To get the geometric interpretation of the flight of the photon. Because that thing cannot both be a particle and a wave at the same time, because it cannot be both discrete and continuous at the same time. And the key word is time. We've always quantized time. We've never treated time as a continuous aspect. But it is continuous. Is space? How do we know that time is not quantized? Do you realize that the current model, the current theory, based on Einstein relativity, they say, is that space is quantized? Well, actually not based on relativity. It's based on Max Planck's discovery of the quantum. But it's mostly based on Albert Einstein's proof that the photon is a particle. Is that true? Let me ask you another question. Did Max Planck actually discover a quantum? In order to get the answer to that question, you have to know how these men derived their solutions. How does Max Planck know to tell us, and we now all accept it, that energy is quantized? Is it? It would have to be if there's such a thing as an electron. It also would have to be if there's such a thing as a photon. But this is seemingly going off the track a little, isn't it? Not necessarily, but I do want to immerse you in what we're dealing with. The quantum paradox is the difference between impenetrability and continuity, as Rudyard Joseph Bošković spelled out on every single page of his monumental work 250 years ago, Theoria Philosophiae Naturalis, which I've read. And I'm not alone in declaring to the face of science that Roger got it. And he didn't use calculus. He did not use calculus. What did he get? He got the force curve for the Bohr atom before the atom was discovered or any part of it, before electrodynamics was discovered by about a century. He got the exact equation for the electron system of the atom. How did he do that? Algebra. It has to be algebra. But that's not the secret. The secret is that he used geometry. And what he discovered, even he did not realize until I came along in 2022, already having discovered the spherical number system, which I just shared with you, although I haven't elaborated it. Let's leave off that story of Rudyard Joseph Bošković's algebraic solution for the force curve of the atom. That obviously would be more than one wave if it's a curve, because the atom has many shells. Indeed, the Bošković force curve describes the shells, but more importantly, it describes the inner shell. The inner shell, which can be modeled on one proton and one electron, of which we have great familiarity, because it's not complicated. There's no neutron, and there's not more than one proton, so there's not more than one electron. And those are three different aspects of what physics has taught us. But with one proton and one electron, the electron makes a sphere around an impenetrable center, and that sphere is continuous, and the proton is discrete. The proton is discrete, but the electron is continuous. I have not gone beyond anything that is stated in particle physics thus far. But there's your center of the universe. There are two problems with that, and so I'm going to bypass that whole line of argumentation and leave you hanging. In order to get to the theory of everything, we now know how to state it. The theory of everything is to make an equation that's a relationship operator of equality in numeric form. The equation of G and Q. On the G side, currently, we have space-time that I've reformulated into a spheric solution. So we have two solutions for G, mine and physics. Except that this is the hypothesis step. So that's G, one of two solutions. Einstein's space-time, yes. It's really Minkowski, Lorentz, and several other men. Einstein was not alone in discovering imaginary 4D space, not even with time. But it was Albert who solved it with a couple of amazing insights, one of which is geometric. I'll say at least one. So Albert's space-time we're going to deal with because I validated it. And so you know what the space-time solution entails. And so you'll see the hole in it, because there is a hole in it. It's the solution for Newtonian gravity exactly, and Newtonian gravity is actually captured in Einsteinian gravity, so Einsteinian gravity is a refinement. The Newtonian gravity is not disproved in any way, but to make it better is considered to be obviously better. How did he make it better? He incorporated the time differential, which is encapsulated, for the sake of a human mind trying to grasp this stuff, think of it as simultaneity. In a volume space, for gravity would be a large volume space like for the Earth or for the solar system, you need to take into account the time lag from one end of the volume space to the other. And that's called the time differential. And that is a calculus term. And that indicates the hole in the system, is because you were forced to calculus. But Einstein incorporated two things. It works. There's nothing wrong with it. That's why I'm praising it to the skies. So does physics. But they don't see beyond it. It's a linear system. It uses a grid. And the magic is the imaginary axis, because that gives you a spherical function, which Einstein had to have, but nobody had ever had to solve this problem before. Einstein solved it. He worked out the time differential for every single particle in the system. That's a monumental task, which is now offloaded to supercomputers, because a human being cannot do that equation. Only a supercomputer can. Interesting, yes? But you can still conceptualize it if you can understand pseudo-hyperbolic space and imaginary 4D number space. And if you can do that in under 16 years, you're good. If you can do it in under 8 years, you're probably a genius. And if you can do it in under 4 years, you're a prodigy. Is to understand exactly, numerically and geometrically, which you need to do to understand it. Einstein field equation for gravity is spacetime. A 4D, that means 4-line, linear system, with an imaginary time axis. And that's the solution for gravity that physics accepts as the Holy Grail. Only I blew it out of the water. But in the same way that Einstein blew Newton out of the water, you don't blow Newton out of the water and you don't blow Einstein out of the water. What you do is, you see it the way he might have seen it if he knew any geometry, which he did not. He learned it fast, though, and he learned the hardest form of geometry known to man, pseudo-hyperbolic space. That's a mathematical space. Does not exist in nature. The Einstein field equation, when it's drawn in a 4D grid, which can't be done for human perception, but it can be projected down to a 3D light cone. That's worshipped. It's worshipped as the epitome of linear algebra, which it is. It's a miraculous solution, and it fails at the center of the cone, because that's linear zero. So there's a hole in the system called a singularity. The same error, it's a mathematical error because you're trying to use zero in proportional space. And I have proved that linear zero is nowhere to be found in the universe. It doesn't exist because it's a derivative number. Because the linear number system, according to my antipodal theorem, proves that the line is embedded in the sphere. And you could actually prove that to yourself visually without lifting a pencil. When you draw a line the way the Greeks did, and it hits two infinities, that's the infinity of the sphere. And that can be proved rigorously. What is miraculous is that sphere can be composed into a number system that accounts for infinity and accounts for the quantum. And this is where you'll get the definition of Q. But you know that Q is a paradox, because it's always two things that cannot be both. I'm now going to show you the solution to that, both numerically and geometrically and visually. This is going to be now hyperperceptual space. That's its correct scientific term, and if that scares you, it bloody well should, because you're now risking your mind. Don't worry, though. You won't lose your mind. You have a built-in anti-centrifugal protector. You won't lose your mind. You may get dizzy, though, so hold on and think. Be sure you're trying to visualize what I say. You have the center of universal space. That would not be the universe, because if it really is the proton, which is bending space, and in integral form bends space with planets, and with stars, and with a galactic system, and with systems that are higher than that, obey the principle of gravity exactly proportional to the number of protons. That has been proved. The reason why nobody says this obvious fact is that, let me tell you what the obvious fact is in scientific formulation, is that if you have a center, the universe does not have that center. So this is artificial. And you must think of this now as just a proton in empty space. And what does it do? We know what it does. It bends space. Einstein proved that, but he didn't say it was for the proton. But now you can see that of course it is. Because only the proton manifests the centripetal force, which is one of the two spherical forces in the universe, the other one being centrifugal force. That's tautological. None of this is new. It's just nobody's ever said this. So one of the two basic spherical forces that are opposite each other, What is centripetal pulling space in? You can only guess what the other one is, but it has to be there according to not only Emmy Noether, according to her Nobel Prize winning discovery of conserved force symmetry, but also according to Newton, who said you cannot have an action without a reaction, and therefore the proton needs another particle. If indeed that's the way the universe is constructed, and I said that quite suggestively, didn't I? Yeah, the electron, that's a wave. The proton is a particle, but the electron is not. The electron and the photon are never particles. They cannot be. It would violate the physical laws of the universe, because you can only have one particle if you define it as G. E is Q. And so they're related. You know what their relationship is? You might say plus minus. That's the linear interpretation. That plus and minus define the proton and electron. Not in spherical space. They're not polarly opposite. They're not plus and minus. The electron and the proton are perpendicular. Einstein proved that. And that proves that what Einstein called time is actually the derivative, if that's the right mathematical formulation. I'm not saying one way or the other, but I'm giving you a word to hold on to. The electron, when it makes a sphere around the proton is exerting a radial force. That is a straight line in spherical space from the center in all directions. That's called the radial line. The sphere is perpendicular to that line. That line that's going out, think of it as going in. And it's a force line. Each line is straight. But taken together, it's the integral of all the straight lines going into the center, the definition of centripetal force. And the sphere made by the electron is perpendicular to that line in spherical space. But the electron only manifests angular momentum. And there's our definition of the central number of the universe. 1 over infinity is the mathematical imaginary center. That center has a geometric radius, where inside the sphere is imaginary space, to the proportion that infinity going out from the edge, which we just defined, is imaginary. And those are the two imaginarities. When you put them together into one number inside of parentheses, is how we notate it, just as with complex numbers, but these are both real numbers. They're both whole fractions. 1 over infinity and infinity over 1 are the two component numbers of your first basis spherical number. This is a special number. But all spherical numbers multiply to 1 on their internal components. 1/2 and 2 over 1 multiply to 1. 3 over 1 times 1 over 3 multiplies to 1. Keep going. The fractions get smaller as the whole numbers get bigger. They all multiply to 1. And so when you get to infinity, that's the last number, but it's imaginary. It cannot be reached, and that's the solution to Zeno's paradox. The center cannot be reached by the fraction to the proportion that the edge cannot be reached by the whole number. This will give us a definition of the center of the universe, which we need for G. When you begin with the two edged numbers, these are the pole numbers, the infinitesimal and the integral. And those are the correct terms. You will accept that because I've proved it. They multiply to 1, and that's the center number. That's the Archimedean of spherical space, to the exact proportion that 0 is the Archimedean of spheric derivative space. And that's why 0 is not a number, but 1 is. It's called unity. Both components have a 1 in them. This component has a 1 over n. This component has n over 1. Whatever n is, the number itself is 1. So every spherical number is 1. What happens when you accept that? Where is the 1? It's harmonically balanced between the center and the edge. And that's the definition of a sphere. So the proton is an infinitesimal sphere if we have a match. We do. And that's what I'm going to prove to you. So hang on. Mathematically and geometrically, without reference to the proton at all, just what we've done, we now have a number that is a sphere. Do you know what 0 is called? It's called a point. That's a singularity. It's a pseudo-infinity. But 1 is a whole number. It's the counting number, index. So these are linear numbers in spherical space. Each one of the numbers in spherical space is 1. But the components change. And that will give us at least the ability to directly relate space and time. Hold that thought. We have two numbers, one which never reaches the center and the other never reaches the edge. Correct? Yes. So, the numbers are diverging from 1. So everything inside multiplied to the reciprocal number outside is unity. So all of these numbers are unity. But the one at the center is the only one that's composed of two infinities. But it's real. And that's the difference between imaginary space and real space, is that the surface of the sphere is the limit. It's the limit going in. The inner limit of the numeric system that the universe uses is a hard ball. But that's not saying enough, because we just defined the relationship between, for instance, 2 over 1 and 1 over 2. This would be the number 2 times the number 1/2. You can see it. The 1/2 is halfway to the center. The 2 is reciprocal out, not very far. When this number goes to 1/4, this one goes to 4. But we're doing it linearly. Albert Einstein proved that I'm wrong to do that. So let's do it right. As the 2 jumps out, that's the quantum jump, by the way. From 1 to 2 is the quantum jump. But there is a reciprocal jump that is perpendicular. And that is the index of angular momentum on the sphere, which is energy. It's also motion, from which we get a derivative, time. And so now we have a definition of a center that has an angular momentum reciprocal relationship with space. And we already know that motion, energy, and angular momentum are directly dependent on time. The outer shells don't even know what time is. but the perpendicular number that represents the index of periodicity on a recurrent action, that's a closed line. That's a closed line. It means it goes ding, 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 ding. That's called frequency. When it's going ding, 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 it has a wavelength that's reciprocal, isn't it? Because if the period is 2, then the wavelength is 1/2. If the period is 3, the wavelength is 1/3. We have an oscillator. And that defines the waveform of the sphere. Its angular momentum projected to a sine wave. That's a wave. That's the electron. And that's why the electron travels perpendicular to the radial line of centripetal force. And that directly implies that the electron manifests centrifugal force. The other force that balances centripetal is manifest in the electron. And those are the only two dual particles in the universe. And as for the subatomic particle physics model, you can cash it in. Because this is the answer, you missed it. The electron is centrifugal force, perpendicular to centripetal force, manifest as a spherical orthogonal angle, and now Ruger Joseph Boshkovich will give us the algebraic curve for the transition from space to time on a curve. That curve is the quantum. We'll be right back. Stay tuned to Anagalactic. This is the first in a series of lectures that will run through 2024. I hope you had a good time.